Okay, my name is Brian Zonstecker, and my company is Power Rocks. And due to the, I guess, massive nature of the topic and the limited nature of the time, I think I want to give a couple disclaimers here. First of all, actually, this kind of reminds me, my wife and I eloped, and we did our own vows. And without going into detail on that, one involved in mine, one of them started with, I had a nightmare the other day. And I won't finish that story, I can talk to you about that offline. But it kind of reminds me of this too. Because this is such a big topic, you probably want to get a lot of detail on this. So I can tell you ahead of time, you will be severely disappointed by this presentation. So now that we got that out of the way. So what we're talking about here, and I'm a power guy, just to preface this also, I come from the server power world. So I'm not a long-time cellular network person. Actually, this is something I got into in the last year because of my interest in 5G, because of the major power implications. So keep in mind as I'm going through this, there will be an emphasis all the time on the power implications. And this is also an excerpt for this short talk today. It was an excerpt from essentially a half-day, 3-hour workshop I put together on this that still is essentially an intro to this topic. So for that reason, a couple things are mostly in the slides. Also, if you download them later to look over in detail, but a couple things I'm going to glance over pretty quick. Just kind of make a quick point, but I'm not going to dig into them to try and keep up with it. So, keep talking about time. I'm yakking. I'm not even into it. So, today, like I said, will be a very brief introduction of 5G for the most part. If you don't know what things like 5G, SDN, and NFV are, you probably wouldn't be sitting here. So again, I will not be spending much time on that. Ditto. And then, of course, the same thing with we'll look at kind of a general characteristics of a telco data center today, and then try and focus on which aspects will be most impacted, in this speaker's opinion, by the movement to the, well, I say the promise of what 5G will be, since what it actually will be is still a couple years out at least. But the takeaway here is it really is changing the landscape, and again, as I'm biased from a power perspective, changing something from a power perspective, from both the kind of what I call the power value chain, from power plant to load, as well as things like all the way down to distributed power, onboard power conversion, has a major impact to everything from hardware to software to application and whatnot. So we said there'll be a power emphasis, hopefully some conclusions, and perhaps some time to discuss something. So very quickly, we just need to know why, in terms of market motivation, I just want to clue into a couple little things that are, to me, will really, signify the major shifts that will be associated with 5G. So one key thing is just, where the areas of growth, right, are typically in the regions that are not the densest cities. It's not all. There's a lot of talk about accounting for densification, but really the major projections for growth, right, are in the areas where they don't already have existing networks, where living by your phone is the only way you're connected to the world. So things like India and sub-Saharan Africa, and these markets are actually the ones projected to have the most growth and benefit the most from something like 5G. And by the way, guys, just so you know, regardless of how the summit makes the slides available, there's everything here and every image, everything is referenced in the back, so there's nothing you can't get afterwards, so just so you know. Again, this is just kind of re-emphasize the point and the direction that it's going in and in the regions, right? That we already have this type of high-speed penetration and projected especially in North America and Western Europe. So it's these other regions that are actually ripe for the most growth, and therefore are going to have the, I would say, require the most foresight and thought into implementing these newer architectures. So where does 5G come from? Didn't want to spend too much time on this. In my opinion, it's kind of a perfect storm thing. That, and this is one of those stupid graphic things that you spend way more time on than you should. So because of that, I have to gratuitously take advantage of it. So I saw it as like a perfect storm of things, of technologies and opportunities and markets. So essentially, you have your SDN, your NFV, your software-defined, virtualized everything. Certainly in the RF area with very high bandwidth, centimeter, millimeter wave band stuff, specific antenna beamforming, slicing, massive MIMO, all these really cool things that we don't really have time to get into, and especially the RF stuff is a little bit out of the context of this discussion. But certainly, as everyone knows, there's an ever-growing pressure and demand driven by the consumer market for, cheaper, faster data, which leads to the, all the way back down to the spectral, the energy efficiency, that, it not only has to be technically feasible, but it obviously has to be financially viable. And then the hotspot density is another really interesting aspect that I think drives a lot of the major paradigm shifts that will have to that are required to deliver on the promise of 5G. So, and to me, intelligent power management is always the key to everything. So this is a common theme you'll hear me mention a couple times, that just bumping up efficiency in power conversion does not yield nearly as much benefit as using your watts in a smarter way, and therefore, I say enhanced power utilization. So, and of course, there's the cute graphic. Oh, it rains. Everything was worth it. Okay, so for 5G, again, I'm not going to spend much time on this. I think everyone's seen all this stuff in one form or another. The high-level benefits, right? Low latency, high bandwidth. Everyone, a billion, trillion devices will be connected. And of course, everyone has their own definition of this. One thing just to be clear on is, especially a lot of the telco operators will tell you they have 5G, what their plan is for it. Just to bring a little reality to it, right? And this, as an example, this one is, I think this is Nokia's, and they call it 4.5, 4.9G. The main point is, the actual standard isn't coming out to the 2019, 2020 timeframe. So that's where there's a lot of things that may be billed as 5G-like, or what I commonly refer to as the promise of 5G. But actual 5G, in terms of the standard, isn't going to be there till this timeframe. So things like, even South Korea talking about the 2018 Winter Olympics, Japan saying they're going to have it for their 2020 Summer Olympics. As you all likely know, even from just the time that the standard comes out, then there's time to deploy this in a production manner. So, until that time frame, between now and then, everything is 5G-ish, or that's why you hear things like 4.5 or 4.9. But just to be clear, just to, like I said, bring a little reality to the difference between the marketing term for that and the actual network is and time frame should be something you're aware of. So what is 5G? Well, really simply, there it is, right? I think it speaks for itself. And there's lots of different graphics like this, but I mean, the point is there's a change in the traditional cell network today that has a core network and a core telco data center, some major backhaul and front haul, which goes to macro cell towers primarily. That service many users in a larger area, and especially as Jeff segued to in a great way. Thank you, Jeff. And also, actually, there's a pretty good talk from Nokia yesterday that really highlighted the idea of, we're coming from this global cloud and we're coming down these levels. Like you talk about the fog is coming down a level. I said a talk the other day where they claim to bring you down into the mist. So, whatever, even if you're now taken down into the water vapor or whatever, the point is you keep getting into a lower level granularity that gets you straight to the edge, which eventually basically brings you to this, or any other device like it. So that's why things like, and I'll talk about this a little more in future slides here, but things like, it's not just something that's things like mobile edge computing to serve these devices at the edge. At the bandwidths and latency requirements, it's an absolute necessity that a lot of this processing is done at the edge and never finds its way onto the core network. And for me, that's an incredible opportunity in power utilization optimization. A really fundamental key characteristic of these 5G networks is the idea of these het nets, right? These heterogeneous networks, where now it's not like all these operators have their own infrastructures and services, plugins, whatever you want to call them, is that now everyone has to play together nice in the sandbox. That a user, a 5G user that's moving from small tower to small tower or small base station to small base station that only supports a very, especially if it's a high bandwidth, very high frequency type of stuff, supports a very small, limited range. So they have to, be able to pass them off from one to the other. And that's why, whether it's densification, which is represented by this darker color, or even some of the non-denser areas where they're a little more spread out, a little more remote. The point is there's going to be huge growth in small cells. So a lot of this is shifting and from macro cells to a lot of these smaller cells. And what that means is if the traffic is shifting to it, the haul and the connection to the network is shifting to it, and therefore the power is also shifting in that direction. One theme that comes out of OCP, and you're probably getting to the point of what the hell does this have to do with OCP, Brian? You haven't even mentioned it till now. So certainly a theme that behooves 5G implementations very well is the idea of disaggregation, right? Because that enables you to densify the individual constituents of a system and then optimize them, for the compute, the memory. If something is more optimized for core network routing versus edge buffering, for instance. And of course, the other beauty of that is the ability to commoditize the solution and kind of level the playing field, or in my callous view as a power and hardware guy, say really the idea is to mitigate hardware into obscurity, really, and even software to some degree. Everything's open so that the app, the user experience is the real product that people focus on. So mobile edge computing, I don't want to rehash this too much because you've heard a lot about it and you'll hear a lot more, is certainly a large enabling portion, especially things that, a lot of statistics you see talking about projections on, overall internet traffic, whether it's today and the growth path, is centered around streaming. So, doing things like having enabling buffering at the edge of commonly used things allows for a much simpler, faster experience for the user, but it's more efficient in the network itself, because today we spend most of our power actually passing data around as opposed to, say, processing it or storing it, whatnot. So the more that's done to mitigate the movement of data, the much greater overall efficiency from a power perspective that you're going to see network-wide, right? Just off the top of my head, I mean, today a cell network is, something like, 60, 70% of all the power consumed in an entire network is in the base stations, right? And that's mostly driven by the PA power, right? The RF PA. And that will dominate, anywhere from 70 to 90% of the base station's power. So a focus on reducing and optimizing that yields the most benefit to the entire network power utilization. And like I said, there's a lot neater things in the RF area for reducing power consumption and optimizing that user experience, but it's kind of outside today's scope, so we're not going to really have time to get into that. Talk to me offline more about that. Also, in the interest of time, I'm going to really breeze over the SDN NFV stuff, because I said I like this graphic, right? It's pretty simple. I think it's self-explanatory, right? But essentially, we know what virtualized software-defined solutions are, right? We take our hardware, we pool it virtually, and we slice it up as need be to optimize for our application. Same thing for whether we're talking about in the data center, typically more in the SDN context, or for network functionality, which is the NFV portion. Ditto. So for 5G, is that nice? Is it a feature add, or is it a necessity? And in my opinion, it is an absolute necessity, because if you want to not only handle the amount of users and the handoff between networks, and then even to go a step further, like Jeff was talking about, things like network slicing and radio slicing and kind of network as a service. It's going to require software control, monitoring and control on both a kind of localized and network level, working cohesively to deliver that. So again, getting back to the heterogeneous network theme of sharing from base station to base station, and quickly handing off and still maintaining the bandwidth and latency specs. Are absolutely going to require the need of software and virtualized controlled solutions. And particularly, you can see I like this graph because it kind of it says, okay, now we're opening up lots of doors for not just getting straight to the UE on the edge, whether that's line of sight or Wi-Fi or even backhaul and front haul that can be wireless or wired. Kind of explains that you want to have all your options and be able to be adaptive on the fly to what makes most sense based on the load, the user profile, and everything else. So, getting to the meat of it now, the telco data center. What really differentiates this from a typical data center? Well, certainly, DC distribution has been around for as long as there's been telco data centers. Actually, on the show floor, especially with, there's talk about when Google came in last year and brought in the 48-volt rack concept, and I see things now that talk about 48 volts like it's the newest, greatest thing out, newest revolutionary thing to come to data center power, and it makes me chuckle a little because it's actually the most legacy power distribution I think there is in the data center world. And that's, of course, we don't have time to go into things like HVDC, 380 volt or any number of other higher voltage DC standard implementations and all that. And certainly there can be a level of robustness like the NEB standard that require a higher level of ruggedized hardware than your typical commodity data center solution. So and as a power guy, I said my real emphasis and interest is where are these watts being consumed and how can we consume them more intelligently. So that's that concept again, intelligent power management, which we'll talk a little more. And really, this key thing right here, I think, is the key to understanding the whole major difference in what I'm calling a paradigm shift of moving to 5G. Because you may say, well, 4G and LTE today does already implement things like SDN and NFV and even some of the more advanced RF techniques like beamforming and whatnot. But what's really going to change is moving from these large macro base stations to requiring so many of these small cells, right? Whether you call it macro cell, nano cell. I even, in my research, I even saw some stuff about an atto cell. Right, and so the point is that each of these small cells now essentially needs to be its own telco data center, right? So even a small, down to the smallest, basically a base station that serves, may only serve a 10-meter diameter, but and can provide high-speed data and has a nice beamforming array and whatnot. Still has to keep all that, keeping with the spirit of mobile edge computing, is going to have to try and keep as much of that as edge as possible. And there's kind of a simple example we'll give in a second. But that's what's really going to drive a paradigm shift in power as well. because you have a network today where you have a lot of core networking, you have these macro base stations that may be on the order of 1 to 2 kilowatts, and now you're shifting that to a heterogeneous network of many small cells that may be down to tens of watts or even less. And so the question, the simple question I would get on this is, well, what's more efficient, right? And say it's not really that easy to say, because there's a whole lot of knobs involved here. And if I said in an area where there's 2 macro cells serving a few hundred people versus 50 femto cells serving the same amount of people, which is more power efficient? Small cells, I have the ability to turn them on and off more dynamically, which is ultimately the most efficient thing, as I like to say, is something that's off. And there's, you mitigate some of the Hall, which consumes a lot of power, as we discussed before. So it's a multifaceted issue. It's more difficult to assess, even if there's incremental improvements in just the hardware itself along the way. So, and again, the telco data center, I'm not going to belabor you with the basics of what make up the data center here. I mean, the main constituents that on the internal side, the WAN, the long haul connection, and then the kind of the edge data center, and these lines are graying. But so where 5G comes in, and I'm running out of time here, like I said, 4G LTE has already brought a lot of these characteristics, but now to really kind of go all in on these small cells is where it becomes most interesting in terms of the opportunity for improvement and optimization. So, I'm even waiting for something like, small cell virtualization, where essentially, you take a group of these small cells or base stations and virtualize that as I guess it's now we might call it a vRAN today. And you have to excuse my ignorance in this area. Like I said, cell network architectures are not my main area of expertise. But the takeaway message is everything gets more virtualized and cut up at the that's the going theme. And so let's see, we talked a little about mobile edge computing, shifting utilization and buffering at the edge. So how does this play into power? This is certainly the mobile edge computing is the absolute largest opportunity to save power. For base station caching, when these things are smaller too, you can have them more specialized for specific tasks. So whether something's for video buffering, or if it's just for buffering of control for the local heterogeneous network or optimization of routing. And I kind of think from a power perspective, it's kind of a brilliant strategy of tricking the customer into paying the power bill. Anyone who runs or is involved in a data center knows that, especially the more hyperscale and commoditized it is, that the power bill, right, certainly typically dominates the OpEx. And to a lot of degrees with commodity hardware, that actually dominates the total TCO, right? Even dwarfing the initial cost of the hardware itself. So, imagine that with mobile edge computing, sounds great, delivers on the specs, the promise of 5G, the user is happy, but do they realize now that with all the processing and everything that's done at the edge, really, all that compute and stuff that used to be done in that core data center is now being done in their phones. So who's paying for the watts to run the processing and the memory and the transport of all that? Well, so in a way, you've kind of tricked the consumer into footing some of the power bill that never has to make its way to your data center. So, interesting perspective. And I like to kind of, I think, sum it all up with the case study, what I call is Grandma OK. And this is more of a thought experiment in what it means to be, power efficient. Now, you have grandma, she's in her house, you're not there, she still lives on her own, you wonder how she's doing. You've taken advantage of everything that you know, the IoT devices and wearables and trackers and everything gives you, and she's all wired up, her house is wired up, and you can track all of her health metrics, her movements and everything, so that you know, you can feel confident, is grandma okay when I'm not around? Okay, so that's the fundamental question right now. I wake up this morning, I want to know if grandma's okay. Now with all these devices and sensors and processing, you know, there's tons of data that can be generated and processed and passed to the cloud or whatever. But fundamentally, I just want to know, is she okay, right? And so it's something much simpler, right? If everything is processed in her house by her devices, and somewhere in there there's a consensus that can just report outwardly to me, the only thing that has to be transmitted is a single bit, right? It can be as simple as that. I mean, I'm oversimplifying. Don't hit me on packet headers and, you know, things like that. But the point is, if all I really want to know if she's okay or not, you know, I don't need to pass all that data up and process it and share it and store it forever if it's not fundamental to what I'm trying to accomplish. So another interesting thing about all these migrating to many more smaller cells is that it actually yields a lot of energy independence. It certainly enables the ability to use microgrids and other sources of power. So you know, if you don't require as much power to run your network or connect to the larger part of the network, then that kind of frees your ability on the source of power, you know, redundancy in solutions for fault tolerance, and by lowering your overall power consumption, you know, you also reduce things like you know, like storage and holdup and other things that lead to redundancy, cost, and power waste. And a separate area of interest of mine that I think marries nicely with this topic is energy harvesting. Once you get moved to these tiny cells that have such low power requirements compared to the legacy macro towers and whatnot, they actually become candidates for other energy harvesting solutions that are not just, you know, large-scale PV systems and all that. So speeding up here, let's see. We talked about disaggregation already, and the ability to kind of bring a steady state-like performance profile to, you know, fairly predictable dynamic loads, which when you're not using something, you can put it to sleep. So what I'm getting at is, for the first time ever, announcing right now, is the introduction of the OCP telco cell, small cell deployment. It's a time, and before I see the worried look on some of the OCP community leads' faces. So this is something I just made up. It doesn't exist, so don't get too excited. But the point is if there's going to be this many cells, and we want to keep in the nature of the OCP spirit to standardize and commoditize something that are small and supposed to be completely ubiquitous and everywhere, it seems like that would be a pretty interesting specification for, you know, something that operated in an OCP piece of, you know, complete system that I could hold in my hand and deploy. So with that, like I said, there's a lot of agreement on what 5G should be, but keep clear that it still has not come to fruition, and we don't know what it really is for at least a couple more years. The base station is becoming the data center. That's the key takeaway, the major paradigm shift here, which therefore relates to power. So intelligent power management also becomes really key to enabling those 5G networks by the ability to wisely control these things, turn them off, and simply mitigate the movement of data where we don't need it. So also said virtualized, software-defined everything is integral to this. As I keep tying things to power, as I'm biased too, I implore all of you who are involved in actually architecting these networks to keep that in mind from the power perspective, so that you're architecting that well proactively ahead of time and not seeing it as an issue you have to deal with once you have a deployed solution, which is the common plight of any power engineers, they'll tell you. So with that, thank you very much. Appreciate your attention, and I don't know if we have any time for questions. One or two. Otherwise, feel free to come and talk to me. I'll be around all day today. Thank you very much. Questions? Sir?
You make the assumption that SDN, NFV would lead proprietary appliances, the firewall that can be made under class process commanders A update though. And this box costs a lot of money, it's inflexible. I want to go with the virtual network function, the virtual firewall that will run on a stack of x86 servers. So I need multiple server to reach the same throughput that these proprietary box. I would end up with way more higher power consumption than using the old stuff as before. So I don't see the equation as one that low power consumption.
Well, and so, and again, just to be clear, I am not someone who architects these things. All right, I see it as something that is enabling and required to meet some of the promised specs. So, for instance, the handoff of of an active user, still maintaining their millisecond or so latency going between heterogeneous cells and networks is required in a software-defined virtualized function, as I understand it. I mean, like I said, you architect and tell me, but where my input comes in is seeing that if this is the type of architecture and solution that's implemented, I can surely see the opportunity to impact power utilization. Like for instance, having a small cell that you can turn on and off in a matter of milliseconds and save that, that huge piece of the power pie from the PA, which is the largest piece of the pie in the whole network, versus a macro cell tower that, may take minutes or hours or essentially is not turned off for that reason, is facilitated by SDN and NFV, and therefore leads to an opportunity for major savings in power utilization. Did I answer your question? Okay, we'll talk more later. Anyone else? All right, thank you very much again.